And then I came to Germany for my master's, and I did my master's in Göttingen in plant breeding. And then I worked 1 year in an organic breeding company, and there I worked on triticale and pea breeding. This brings me in my PhD project, where I worked with Professor Thomas Doring in the University of Bonn, having fava bean and spring wheat, different cultivars. Yeah, so today I will talk about the height evaluation of multiple spring wheat cultivars in diverse intercropping system. This is part of one of my published papers.
Try again. Can you try again?
Yes. So intercropping, yesterday we talked about a lot about intercropping. Is why is not working?
Doing anything? Oh, okay, that's weird. I've got it selected. I'll select this one. Try again. Okay. Try again. Okay. Can you use the arrow? Yeah. It's okay. It's a computer.
That's okay.
Yeah, it's all connected. It worked before. It just doesn't work anymore. Does the laser pointer work if you click it?
No, it works sometimes. Sometimes it doesn't.
You're not pointed from the generating. Okay.
Sure. Yeah.
The stick is.
Just use space. Is that okay? Or the or that one. Yeah.
Okay, so yesterday we talked about intercropping, and we know intercropping is cultivating plants simultaneously in the same fields, and we also know the advantages of intercropping. It's produce higher yield with limited resources. For example, particularly in organic agriculture, where the soil N is the availability of soil N is lower compared to the conventional one. And there, intercropping normally proves higher yield. And then it increased the yield stability, work as an insurance for the farmer. Particularly in my first paper, we observed when there is a lower emergence due to some unknown factor, we observed in mixture the overall emergence was higher than the monoculture. This was because probably the compensation effect. When one partner failed, the other partner compensate. And finally, mixture work as an insurance for the farmer. And then it increased resource use efficiency because when you mix two different kind of plants, probably they have different structure. They have different root length, and the deeper root can go deep and take the nutrients and water from the deeper layer, and the shorter one from the upper layer, and at the end you have more resource use efficiency in the intercropping. And it reduces agrochemical use. Of course, this increases biodiversity, and they reduce pests and diseases, because when there is a diversity of crop, the spread of pests and diseases is a bit difficult. It's hampered by the other type of crop which is present there. Recent, not so recent, in 2020, a published paper. This author, he collected lots of paper and see how intercropping was beneficial or not over monoculture, and he calculated LER, which was x-axis, and so basically he observed the average LER was 1.28 or 26 around. That means intercropping was 28 to 26% more efficient in case of land use compared to the monoculture. But if we look at the x-axis, we can see, so there are lots of intercropping systems, which was not beneficial, which was not giving better yield than monoculture. And we can see lots of variation going on also intercropping performance. Because the overall objective or overall positive effect of intercropping depends on many factors. It depends on seed rate, site, which you are doing the intercropping. It depends on managemental practice, what you're taking. And most importantly, it depends on the cultivar or genotypes you took for intercropping. So when you select the cultivar and genotype, the question is, how do you select them? How do you know which cultivar is going to be better in intercropping? And most importantly, which plant trait you think could be important to increase the facilitation effect in intercropping or decrease the competition effect in intercropping, thereby it gives higher yield compared to the monoculture. How do you know? How do you select them? So this author also combined some traits he thought could be important. So he mentioned in early over late maturity for many crops. But most importantly, the character I highlighted, he focused on the plant height, because plant height play a very significant role in competition and thereby to control the overall productivity in intercropping. So basically, it has a very important role. So therefore, in my experiment, we wanted to see or answer some question. So first of all, we wanted to see, is a mixture of spring wheat with fava bean was more beneficial over monoculture? Then we wanted to see, was there any correlation between the spring wheat performance in monoculture with their performance in the mixture? So that means if we select the spring wheat cultivar for the mixture, can we select them based on their performance in monoculture or not? Then the third one, does the mixture effect on total grain yield depends on the cultivars, spring wheat or fava bean cultivars, or depends on the environment, or depends on the crop management? Finally, was there a correlation between the total grain yield in the mixture? The total grain yield means the grain yield of spring wheat and the grain yield of fava bean, the combined grain yield, and the plant height of spring wheat cultivars. To do that, first we selected 10 spring wheat cultivars. They are diverse in their plant height. So this is the score of that cultivars according to Bundessortesam. The lower the score is, shorter the cultivars are. Higher the score is, taller the cultivars are. They are also diverse in their brown rust resistance. And they are similar on ER emergence, maturity, and baking quality. To bring one more level of diversity, we created 2 cultivar mixture group. The group 1 contained the shortest cultivar, 3 shortest cultivar, Lennox, Annabelle, and Jasmine, and the 2 tallest cultivars, Saludo and Sorgos, to bring the diversity in their height, and then we mix them completely and use them as one treatment. So they created the cultivar mixture group 1. And then rest of the 5 cultivars, which are more or less homogeneous on their plant height, we created cultivar mixture group 2. Then we also have fava bean. We have 2 fava bean varieties. The first one is Madhuri, which is a short variety, and Fanfare, which is a tall variety. The experimental site, we have 2 experimental sites. It's in Germany, in Bonn. The first one is Wiesengut, which is the organic side, around 20 kilometers from Bonn. And the second one is Klein Altendorf, it's other direction, also the same distance from Bonn. It's our conventional side. So our conventional side, the soil nitrogen was higher than the organic side, although we haven't used or haven't applied any additional fertilizer or pesticide. But as it is a conventional side and fertilizer is applied previously, there was more soil nitrogen than the other side, organic side. However, the soil water content was higher in the organic side compared to the conventional one. And yeah, so the treatments. First, we have spring wheat at 12 levels. So 10 is the 10 spring wheat cultivars, and 2 is the 2 cultivar mixture that created 12 level, 12 spring wheat monoculture treatment. Then we have fava bean in 2 level, 2 fava bean cultivars, but we replicated them double, so we had four plots. And as a mixture, we have substitutive mixture. So we know we can mix in 2 different ways, either additive or substitutive. Additive, you just add as much as you want to. If you take the 100% from monoculture 1 and monoculture 2, in the 100% additive, you make 200% in the mixture. But in our case, it was substitutive. We take 50% from one monoculture and 50% from other monoculture. We add them, make the substitutive mixture 1:1 ratio. So having spring wheat in 12 level and fava bean in 2 level, we have mixture treatment 24. So each spring wheat with 1 fava bean created 24 treatments. So 12, 24, and 2 double replicated, we had 40. We did it first with high density. That means 120% of their base density. That means the recommended density, we took it that what farmer used in their field. We had 20% more there and created a high density. So all these 40 treatments or 40 plots, we did it also for low density, which is 80% of their base density. At the end, it created 76 treatment. If we consider fava bean doubly replicated, 80 plots per block, had 4 blocks per side, created 320 plots per side. This is a 4 factorial design, designed as a completely randomized complete block design. We had it in 3 environments. In Sika 2020, we had it in Vision Good 2020 and Vision Good 2021. The sowing, the first year, in 2020, sowing happened end of March in both sides. So I need to mention about the sowing. So what happened? First, we needed to sow the fava bean at 6 centimeter depth. And then we sown the spring wheat on the top of fava bean with another sowing machine at the 3 centimeter depth. So basically, the people who sown, they really needed to be right on the correct line to make it really possible on top of the one. And then the second year in 2021, the sown happened at the beginning of March because the weather was warmer that year. Yeah, as a parameter, although we collected many parameters, but for this talk or this paper, I had only 2 parameters, second biomass cut and cut before harvest. I'm saying it's second biomass cut because we also had the first biomass cut, and that happened at one side of the plot. And the second biomass cut is other side of the plot. So basically, this how look like an individual plot. Had 6 rows. We had the cut from middle of the row, leaving around a meter from the side to reduce the age effect from the collected samples. We collected 1 meter long sample. We harvested it. We separated it, the wheat bean. We take the fresh weight, we dry it, take the dry weight, and all the result is depending on the dry weight. And the second biomass cut taken 82 days after sowing. And we also measure the height, the plant height during that time. And then the cut before harvest happened from the middle of the plot. So before I go to the result, we need to understand two indices. The LER, we talked about it yesterday a lot, but still a quick reminder, is a relative land area that was required for the crop monoculture to produce the same amount either biomass or grain yields as observed in the mixture. Basically, the LER is a combination of two partial LER from two partners, from spring wheat and from fava bean. Partial LER of spring wheat calculated taking the yield from monoculture divided the yield from mixture. The same way also for bean. If we put it on graph, put the LER equal to 1. If the points are below 1, means mixture was not positive or giving not higher than the monoculture, and it's gone again. And if the point is above, that means mixture is positive over monoculture. And the next one was absolute mixture effect, AME, is the difference between the total grain yield in the mixture and the average yield of two monoculture. If we add them on graph, it's if the points are negative, that means mixture performing negative, or if the points are positive, means mixture is positive over monoculture. Okay, now let's look our first research question. Is the mixture of spring wheat and fava bean more beneficial than the monoculture in terms of total grain yield? For that, we did AME and LER of total grain yield on the average.
Sorry, quick question. Was the mixture, was it a row intercropping? Was it complete mixture? Perhaps I missed it, but
Yeah, it was. It was, sorry, I have a picture I wanted to show you. Okay. Can you see here?
You don't need to use your mouse.
Yeah. So it's completely mixed in the row. Probably it's not so visible here.
No, it looks like alternate row to me.
I have a better one, you know? It's just I need to go there. Ah, sorry. There.
Yeah.
Right?
Yeah, okay. Here it's very clear.
So we mix them completely in the row.
Yeah, it's precision sewing.
Yeah.
Because they went twice over. That's what you said.
Yeah, so the first research question we wanted to see is mixture is beneficial over monoculture. For that, we did AME and LER of total grain yield on the average of basically everything. We wanted to see how on average, how mixture was performing. Is it better or not? We did an average of spring wheat cultivars, fava bean cultivars, and soil density. So the first we did average on 3 environment, and we can see based on the LER 1.08 and AME 0.28, we can say mixture was 8% more efficient in terms of land use and producing 28 ton per hectare more yield compared to the monoculture. But when we look in the individual environment, for example, the first one, SICA 2020, mixture was not beneficial. It was LER was less than 1 and AME is a negative. Again, the SICA 2020 is our conventional side, and two other side is the organic one. And organic one, we observed the positive mixture effect. Because it could be that the mixture actually doing well in organic side as when the soil nitrogen is low. The cereal, which is a stronger competitor, they can take the soil nitrogen and force in legume, the fava bean, to depend on the nitrogen fixation and the overall have a more nitrogen in the system compared to their respective monoculture. Therefore, we observed a higher mixture effect on these two sides compared to our conventional side. And then therefore we could say, so there is a positive effect of mixture, but it largely depends on the environments. The second one is, was there any correlation between the performance of spring wheat in monoculture and its performance in the mixture? That means if you want to choose the spring wheat cultivar for intercropping, can we choose by looking them in the monoculture system, depending on their performance in monoculture, or we need to try them in intercropping to see how their performance in intercropping. For that, we did spearmint rank correlation between spring wheat yield in monoculture and compare it to the spring wheat yield in the mixture across all 12 environments. So we had two parameters, spring wheat grain yield and the total grain yield, spring wheat and fava bean grain yield. And the first environment in SICA 2020, the correlation was not so strong. It was 0.43. But in the two other environment, the correlation is slowly increased. The strongest correlation we observed in Vision Good 2021. There was a reason because in Vision Good 2021, the yield of fava bean was very, very low. I will show you the picture later on. So basically, the spring wheat performance is not always strongly correlated with their performance in intercropping. That means spring wheat in intercropping did not always show a correlation with monoculture in terms of grain yield. That means we cannot always choose the spring wheat cultivars for intercropping based on their performance in monoculture, as there is not always we observed stronger correlation between those. And the third one is, does the mixture effect on total grain yield depend on the spring wheat cultivar, fava bean cultivar, environment, and crop management? For that, we took two indices, AME, absolute mixture effect, and LER, land equivalent ratio. We did ANOVA of AME and LER of total grain yield, and then we observed that the cultivars, the two species cultivars, doesn't have any significant effect on the total grain yield in the mixture. It could be because so there is only a slight interaction effect between two cultivars, but only for one indices, AME, not for LER. So we assume that it's because those selected cultivar they are bred for monoculture, not for intercropping, and therefore probably that doesn't have any significant effect on intercropping. But however, we observed a slight correlation. Probably there is some potential, so we should look or yeah. And the next is the density and environment, and we observed a very strong dependency of the density and environment on total grain yield. And most importantly, we observed the complex interaction, many two-way interaction between those factors happening there. Therefore, we conclude that the mixture effect on total grain yield depends on multiple factors. Particularly, there are many interactions going on between those two factors, between all those factors. Now I wanted to show how all these spring wheat cultivars that we selected, depending on their diversity and height, how they behave depending on the density and depending on the environment. So this first graph, this is the total grain yield of all the spring wheat, 12 level of spring wheat cultivars. The x-axis with the fava bean cultivar Madhuri, compare it with the y-axis with the other fava bean cultivar Fanfare. And here we can see some spring wheat cultivars. For example, this is for the high density. For example, Sorghos, which was one of the tallest cultivar with the height score 7, performing consistently not so well with both spring wheat cultivars. But however, when you look some other cultivars, for example, Caviar Starlight, Lennox, SUA Half, they were consistently doing well with both spring wheat cultivar. But now, if we do the same graph, but for the low density, we can see their pattern, their behavior is completely changed. So some cultivar like Jasmine is doing well with fanfare, but not necessarily with the other fava bean cultivar Mallory. And this is also in case of Quintus, just change their behavior. Therefore, again, there is a multiple factor interaction going on. We cannot conclude the performance of cultivars because they are just depends on the which factor, which managemental factor, which density you are going to talk about. And this thing also happened when we look at the different environment. Here I took two environment. The first is Sika 2020. The X is the total gain yield of all the spring wheat cultivars. And so, there's supposed to be another bar here. It's not visible here. Don't know why. So this the blue, the green one means the grain yield, spring wheat grain yield, and the blue one means fava bean grain yield. And when you combine them, this one supposed to be here with the gray line, the gray bar. That should be the total grain yield. It's not visible there. So basically, and then we see the other environment. This looks a bit messy, but actually I just wanted to show you. If we look, the first cultivar, Chamsin, which was not which was a kind of a middle height cultivar. It has it's ranking first in case of total grain yield in the first environment, Sika 2020. But when you look the second environment, Chamsin is staying on the last on the ranking. And the other cultivar, Sorbo, which is first in the environment Vision Good 2020, is ranking last. That means their behavior is so much depends on the environment, and there's so much interaction going on. So it's very hard to conclude their performance in general. But however, we wanted to rank them on their overall performance. For that, we took overall AME and LEA, and we try to see which variety ranking first and which variety last. And at the beginning, this is the lower the rank is, better the performance was. Yeah, this is again the score of the all spring wheat cultivars. And we can see that the first three ranking, Quintus, Chamsin, and Annabelle was ranking first. They had around medium-sized height. And two cultivars ranking last, Saludo and Sorbos, they were our tallest cultivar. Therefore, we can say moderate height cultivars, moderate height spring wheat cultivars gave a relatively higher grain yield, while tallest cultivar gave a relatively lower grain yield in the mixture. But again, is on the average of everything. So we need to look to get the clear picture. We need to look detailed what's going on, depending on the environment, depending on the density. Yeah, the last one is we wanted to see was there a correlation between the total grain yield in the mixture and the plant height of spring wheat cultivars. For that, we took spring wheat height against the total grain yield in the mixture in ton per hectare. We observed a slight correlation. And this correlation of spring wheat height could be with either spring wheat grain yield or the fava bean grain yield, as here is just the total grain yield. Therefore, we did the correlation of spring wheat height with the spring wheat grain yield, and we observed a slight correlation. And then we did it with the fava bean grain yield. And for that, we observed the correlation, but only with the tallest fava bean cultivar, Fanfare, not with the shortest one, Mallory. But this thing happened only in one environment, in Vision Good 2020. We haven't observed in two other environments. Therefore, we concluded here a significant yet weak positive correlation we observed with spring wheat height and the total gain in the mixture, but only in one environment. And this correlation we also observed with the fava bean cultivar, with the tallest fava bean cultivar. This brings me my last slides. Here I want to conclude all the findings. So our first was intercropping was indeed more beneficial over monoculture in the average of all three environments, but except one environment, SICA 2020, that was our conventional environment. And then we advise to select spring wheat cultivar and site specific based on their performance in mixture, not in monoculture, as we haven't observed always the correlation between the spring wheat performance in the mixture with their performance in monoculture. And then we also advise to optimize all the system. We need a breeding, particularly for intercropping. Third, when we design this the breeding or design the intercropping system for the farmer, we need to select these two components crop simultaneously, as we observed a slight interaction effect between those two species. And we need to consider the environment. We need to consider the planting density or other managemental factor if we have, because the performance of the cultivars very much depending on which environment, which density we are talking about. And then as we observed a slight correlation between height and grain yield, when you select the cultivars, we recommend to consider the plant height. And as we observed that there is a on average, the moderate height spring wheat was doing better. So we recommended to select moderate size spring wheat cultivar to enhance mixture performance, and taller spring fava bean cultivars to improve the competitive ability of the fava bean, so they can compete the spring wheat, and finally give the overall higher mixture performance. And with this, thank you very much for your attention.